Good morning. We are going to be presenting our passenger monitoring models at Jakarta Bus Stops using YOLOv3. I am Nicolaas Hadisurya. My partner is Jessen. We have two advisors, Lily Ayu Wulandari and Islam Nur Alam. We are part of the BINUS University School of Computer Science. Today we will be presenting to the ICO ABCD conference. This is our group, Jason and me. For our introduction, public transportation plays a crucial role in urban mobility in major cities like Jakarta. Despite this, there are still many challenges, especially during peak hours, which lead to long queues. Study shows multiple types of things that passengers will judge to determine how satisfied they are with transportation. There's still room for improvement in Jakarta's transport services. So we are going to present our improvements and innovations to help with this problem. There's an overcrowding issue at bus stops, especially during work hours, in the morning when people are going to work, and the evening when people are going home. This causes discomfort for public transportation users. Our objectives are creating an AI model that can, based on computer vision, detect the number of people at bus stops, identifying which days and which times have the highest level of density, and providing important information that can be used to monitor these crowd levels at bus stops. These are some of the latest works from 2023. Otsel et al. Presented an automated age system using two cascaded yellow models, identifying the amount of humans complying with face mask rules. Another with facial recognition. This one is focusing on real-time monitoring, measuring social distancing. Another from 2023, using them to detect crowds in real-time videos, also measuring which versions are best. YOLOv3 and YOLOv5 were found to be good. This one from 2021 adapts the model to address the difficulties in identifying specific pedestrians by combining multiple resolutions and other technologies to improve detection accuracy. One from 2020, using local algorithms to identify road objects, including people for autonomous driving. Another one trying to make it more compact, to make it quicker and minimizing the model. Another one, these two, 2021, trying to make it for more devices with limited processing power, making it better but not too low quality. Another highlighting that we need quick detection algorithms if we want to do safe autonomous driving cars, especially for detecting pedestrians. That is very important. One from 2020, training all models for security and surveillance, recognizing people in thermal vision. One from 2022, trying to do quick and precise detection use in drones on search and rescue operations. And here is our methodology. We prepare a data set using the 2000 image from the COCO official website. That's our database. We split it into 18,000 training images, 200 testing. We train the model with the training images. We evaluate the model, how it performs using the 200 testing images, and we will utilize the weights we got from that to train our image input detection. The YOLOv3 is the You Only Look Once version 3. It's for that. Is one of the well-known computer vision algorithms known for its speed and accuracy. It analyzes the entire image at once using a single neural network, which sets it apart from older approaches. Main architecture is called Darknet 53, a conventional neural network with 53 layers. This network uses 3x3 and 1x1 filters and leverages. It skips connection to preserve gradients and increases network depth during the training phase. This is our source code. This is our data set. As said before, it is the COCO, Common Core Objects in Context dataset.
Okay, so these are one of the sample input images. And for its images, it will be accompanied with a label file, which shows the annotations of the bounding box of the type of the person from an image. And these numbers represent the class ID, x center, y center coordinate, and the width and the height of the bounding boxes. And then we also use the YOLOv3 weights file for the training process. This is the file that already pre-trained with the COCO dataset, so it is very suitable for our experiment. And then for the YOLOv3 CFG file, this is the parameter file that is used to train the YOLOv3 model. There are some parameters that we adjust, such as the max batch, steps, filters, and the classes one, because we only want to detect person classes. And this is the comment that we use to train the model. And then this is the result, the loss chart that will be resulted for every training processes. So we are going to see that on the early phase, the loss chart is decreasing significantly, which shows that the model is learning very well from the training set. And then it is reaching convergence as the time goes by at the end of the time, which shows the convergence. So a loss graph can show how well a model is performing. The smaller the average loss, the better the model's performance. And then this is the comment that we use to test or evaluate the model performance. We are using confidence threshold of 0.25 as the minimum criterion for the bounding box to be identified as a person. And this is the performance metrics that we obtain. So positive shows the amount of time that the model able to produce bounding box that correspond to the ground truth bounding box that is defined at the label file. And then false positive show the amount of time when the model produces a bounding boxes that doesn't correspond with the ground truth bounding box. And false negative shows the amount of time that the model cannot identify the person that is already identified in the label file. Precision is, for example, like if the model produces 10 bounding boxes, then it will show how accurate that those 10 bounding boxes correspond to the label ground truth. Recall will show the ability of the model to really identify all bounding boxes that is already that's already defined on the ground truth. F1 score will examine about the accuracy of precision and recall. A first precision will show about the ability of the model to maintain high precision at different recall values. Mean average precision will show the mean of average precision of each class. So for average IOU, it will examine about the average of area of overlap between predicted and ground truth bounding boxes. So we collect the data from Transjakarta University bus stop. This is the day, and then the detail of the day and the time. And this is the image from Monday, Tuesday, Wednesday, Thursday, and Friday. And then this is the comment that we use to run the image detection model, and we are using the threshold of 0.1. And this is the function to show the output. So for the result, Monday, there are 14 people, for Tuesday, 20 people, for Wednesday, 12 people, for Thursday, 16 people, and for Friday, it is 13 people. And this is the bar chart to show the number of people detected on each day. And for evaluating the model performance, we're using a software called Label IMG. This is used to create a annotation of the bounding box around the person from an images. Then we will use these annotations to compare with the predicted bounding box annotations that is generated by the model. And then we obtain that the true positive is 50, false positive is 25, false negative 29, precision 66.67%, recall 63.29%. And this is the formula to find the precision and recall. And this is the table that will show the number of people detected by the YOLOv3 model and by the researchers. So based on the detection results displayed in the experimental outcomes, the highest number of people detected was on Tuesday with 20 people, while through manual observation, it was on Friday with 18 people. These results indicate why there are still many false positives and false negatives. This can be evidenced by the model that sometimes frequently produce duplicate bounding boxes on the same object and mistakenly detect glass reflections as people.
Our conclusion is this area model is already capable of detecting the number of people based on image input, but it still isn't entirely satisfactory. Therefore, further experiments are needed to improve the model's performance so that it can accurately and reliably detect the number of people at bus stops. For future research, we will be preparing a more focused dataset on the bus stop environment and conducting more experiments. Once the model can achieve better performance, we hope that our model can be used to detect the number of people at various bus stop locations and other public transportation safety facilities such as KRL stations in Jakarta using CCTV cameras. Thank you. This is our presentation.